Okay. All right, so we've dealt with hungry cats and ringing telephones, but let's continue on here with chapter 1. So we saw in those last couple of examples, we can have a conversion factor from within some unit systems. We had within the time unit system, we had converting from time, not time, converting from length, not length either, mass, in the metric system versus a regular system, so pounds and kilograms. Conversion factors can come from other places as well, and one of the more common places that we'll find a conversion factor is in a percentage. So percentage is always describing a relationship of part of something to all of something, and it's basically a ratio. It's part divided by whole. And then percent means that it is scaled relative to 100. So that ratio is multiplied by 100. That is how we arrive at a percentage. So when we're looking at a problem and we're given a percentage, often what we'll want to do is pull out this information, because it's actually this ratio that we can use in the same fashion of problem solving to pull out two pieces of information, use one to cancel units, and use the other to introduce a new set of units. So think about that when you see a percent in a problem, that there's really two units hidden in that relationship. And we'll jump right into the example here. So a supermarket is selling ground hamburger that is 12% fat by mass. So this 12% really means there's 12, and since this is mass units, I'm just going to call it grams. 12 grams of fat would be the part in this relationship, and it's hamburger, so 100 grams of hamburger would be the whole in this relationship. And in this case, when we're making this ratio, we're factoring in the 100 there as the total of the sample size. So there's 12 grams of fat out of every 100 grams of hamburger. Both of those are grams, so you do want to be careful when you're doing a calculation. Grams of what might be an important question we need to ask as we're going along. So we look at part A here. We have a package. The total package contains 0.75 kilograms of hamburger. We want to figure out how many grams of fat are in that hamburger. So again, we're going to start with the information given in the problem, 0.75 kilograms. And I'm going to put HB here just to keep track of the fact that I'm talking about the mass of hamburger as opposed to the mass of fat, because that's a mistake we don't want to make in the course of a problem. Now, I defined my percentage in terms of grams, so let's take kilograms and change that to grams so that we'll have the right units to then use the information from the percentage. So kilograms would go on the bottom because that's what we're trying to cancel. Grams of hamburger would go on top because that's what we want. That relationship again is out of the metric system, and one we should be familiar with, 1,000 grams in a kilogram. That would allow me to cancel out kilograms of hamburger. My units now would be grams of hamburger. Well, now I can use this information that was hidden in that percentage. There should be 12 grams of fat for every 100 grams of hamburger. That would allow me to cancel out the units grams of hamburger, and now I have grams of fat, which is the unit that I want for my calculation. So the units all worked out to give me the right units. That means the numbers are arrayed the way they should be for me to do the calculation. So anything on top I'm going to multiply by, anything on the bottom I'm going to divide by. I'm going to leave out the ones because dividing by 1, multiplying by 1 doesn't change a number. So 0.75 times 1,000 times 12, and then I'm going to divide that quantity by the 100 that is on the bottom, right? And my answer here comes out to be 90. Now we do need to look at Sig Figs. We started with a 2 significant figure number. This conversion factor is exact, right? A percentage, the 100 is exact because that's how we define percentage, as the relation to 100. But the other part of the percentage is going to be measured. So that's also 2 sig figs, but that means our answer should be 2. So I'll put the decimal on there so that I'm specifying that that 0 is significant in my answer. Okay, now part B here, if we are only allowed 3 grams of fat per day, how much hamburger could we eat? So we can start that off. There's just that one piece of data provided, 3 grams of fat. Right? And what I want to do is convert this to grams of hamburger. Well, just like any equality, the top here, grams of fat, is equal to the bottom. They're representing the same quantity. So I can turn this over if necessary, and it would still be an equality, and I could still use that as a conversion factor. That, in fact, is what I need to do here. I'm going to invert the information in my percentage and put 100 grams of hamburger on top and 12 grams of fat on the bottom, because that's what I need to do unit-wise to cancel out grams of fat. And keep that in mind. Anything that's set up as a fraction that's an equality, we can turn it over if it's appropriate for the units. Now, how much hamburger could we eat? We've got grams of hamburger or mass of hamburger, so that is the only step we really need here to finish off this problem. So 3 times 100 divided by 12, and that gives me 25 grams of hamburger. We started with 2 significant figures, and again our percentage, the 12 is 2 significant figures relative to the exact 100. So 25 grams of hamburger. This is the step that will often be the one that gives people a little bit of trouble. So keep that in mind. Just be aware of the fact that if you're following your units, it's okay to flip over information. If it's an equality the way it is, the way it's provided right side up, it's still an equality if you turn it over, if that's what you need to do for your units. Now, let's see if we can get one more problem in here before we switch over the video. So one more example here of using conversion factors. In this case, a conversion factor is provided in the problem. And that may introduce a different issue we need to address, but let's just look at the problem. The dose of a drug is 2.00 milligrams per kilogram of body weight. So we've got units of milligrams in terms of the drug on top of the fraction, kilograms of body weight of the patient on the bottom. And we want to figure out what would be the correct dosage for a child that weighs 45 pounds. Now, what may be tricky here is there are 2 numbers given in the problem. So we need to figure out which is the appropriate one to start with. And what you want to look for, the 2 here has 2 different units associated with it. So it is a fraction in terms of the units. It's already a conversion factor. The 45 is not. The 45 just has 1 unit, so it's just a piece of data. We always want to start with the quantity that just has 1 unit. And the reason that we do that is because it shows us exactly what to do in the next step of the calculation. Now, you might be able to look ahead and figure out how the dosage here is going to enter into the calculation, but that's a little more complicated than we need to make it. If we start with pounds, we just need to cancel pounds in the first step of the calculation. Now, canceling pounds, if we can get to the unit we want to cancel in our dosage, then putting in the dosage would be the logical next step. We're going to want to cancel, since this is the body weight of the patient, we're going to want to cancel that with kilograms here. So I want to convert from pounds to kilograms. And we saw that conversion factor earlier. 1 kilogram is 2.205 pounds. That gets rid of pounds as a unit, introduces kilograms. And now if we put kilograms on the bottom here, milligrams of the drug on top, that will cancel the units going with the body weight of our patient, and it will leave us with how much of the drug should be weighed out. Now, it's per kilogram here. You can put a 1 in there if that helps that make more sense to you, but often units will be described that way. It's just mass per kilogram. It's kind of understood that it's 1, but again, a 1 on the bottom doesn't really change the numbers at all. So you don't have to put that 1 in there, but you can. It's kind of your choice. That cancels out kilograms. And now again, everything is laid out here in terms of what we need to do. So 45 divided by 2.205. And then multiplied by 2 there in the last step. So my calculator says 40.816, but the data we started with here, the mass, was only 2 significant figures, right? This was 4 versus an exact. This is 3 Sig Figs versus an exact. So 2 is our limit. So 40.816, I'm going to round up to 41. So 41 milligrams of the drug is what we would want to weigh out to administer to that patient. Okay, one more topic in chapter 1, which is density, and we should be able to fit that in to one more video.